Hi. Today's video I want to start working on revamping ControlLogic 1 and get it dialed in using the HC logic ICs. ControlLogic 1 is intended to handle the full gamut of address bus 1 asserts and main bus asserts. And the hardware associated with that should be relatively static from here on out. The firmware, on the other hand, will get updated still quite frequently as I continue to add additional registers and devices to the build. Once I get that done, I also have a solderful breadboard. So this is actually in a breadboard form, but you can solder onto it. And I want to build out a new EEPROM replacement following the relay model that I've been using and has been working successfully. I want to get that integrated into the new ControlLogic 1 build and then get that into the overall build and test it. A lot to do in this video. Let's get into it. Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey. First thing I want to do is focus in on the section that I want to be dealing with today, and that is these two breadboards here. So here's the center line of this breadboard, and here's the center line of this one. This belongs to the ALU, so that's not in play there. I need to pull these two out, and ultimately I want to set them right below this, which is where I'm shaping my clock. And I do want to try to deal with this delay and get this cleaned up today as well. But to do that, I really need to make sure that I get the timing correct for the signals coming off of Control ROM 1. The next thing here is I actually want to get something a little bit better in this spot, since this should complete the hardware portion of ControlLogic 1. I should not be looking to add anything more into this particular section of the build. So I want this to be a little bit more robust, and as a result I'm going to use this solderful breadboard. Basically it's a breadboard, but I get to solder onto it. So I want to I want to rebuild this onto the solderful breadboard, and it's two-sided. So hopefully it'll be a little bit easier to deal with than this single-sided strip board that I've been using so far. What I hope is that I should be able to build all of this up on here and get it set into place here so that it just slides right in perfectly. For ControlLogic 1, I want to go through and take a look at the signals that we're dealing with here. And there's really two types of signals that are involved in ControlLogic 1. The first is everything that is going to assert out onto address bus 1. Now, I may or may not have defined this, and I don't recall that I have or not, but address bus 1 is really just the program counter. So this is going to be reading instructions out of memory and putting them into the fetch register. And there are four places that I envision that I will be executing code from. The program counter, potentially the return address register. We can get into that in a little bit. And then I plan on having interrupts. So there's going to be an interrupt context and a normal run or user context. And in the interrupt context, I've got also the program counter and its return address register. Now, I've not talked much about interrupts, but once I get things settled and I get my ALU actually working, I do plan on spending some time in building out how I'm going to handle interrupts. The second component on Control ROM 1 is everything that will assert out onto the main bus. And you can see I've got 12 general purpose registers, my stack pointer, my return address register, my program counter, my interrupt related stuff, my fetch register is there. I've got room for 10 devices, more on that later. ALU and memory both need to be able to assert out onto main address bus 1. So each of these devices has a data component that needs to interface with the main bus, but then potentially a control component that also needs to interface with the main bus. And those 8 bits, so 6 bits for the main address bus and 2 bits for address bus 1, are the entire gamut of everything that I can address, if you will, into this Control ROM 1. And so I want to get that all built out, or should I say rebuilt. I believe I'm going to need to place this onto 2 breadboards. Actually, I'm quite certain I'm going to need to do that. And so the first thing I want to do is make sure they don't slide all over everything. And so I want to get those locked together. So let me join power, ground, get decoupling in here, and then I'll come back with some component placement. You've seen me work on most of this before, so I'm going to breeze through the more mundane pieces of this quite rapidly. Okay, that done. I've got control ROM 1 I need to place in here at some point or at some place. But then I also want to be able to latch the output that's coming off of control. Wow, that's a bad glare. That's coming off of control ROM 1. But over here on the side, I still want to be able to have room for my clock lines. Now that would be the clock, the inverted clock, and what I'm calling my spiked clock. So let me get those jumped here. I'll make sure those are nice and clean, and then I'll come back with some gross general placement of each of my components here. Now with that, I'm going to move my control ROM over 1. I'm going to leave 2 spaces there. I need a demultiplexer for the address bus 1, and then I need 6 demultiplexers for the main address bus. Finally, I really do want to place down here that I can land all of my signals to take them off the module. So I'm going to move this up here. And I think I'm going to try to make that work. Power and ground is one of those things you've seen me do a million times before. While I was at it, I went ahead and took care of the IC level decoupling as well. That gives me decoupling for everything. Now recall that because I'm going to be taking this in and out, I'm going to need to have access here to this. As a matter of fact, I'm going to need to move this bulk decoupling on the power rail over so I have access here. Okay, the next thing I want to do is I want to get this EEPROM wired up. And I'll make some room up here because up here in the corner I'll stick a pin diagram. So I want to bring this into the picture now because each of those address lines I do actually want to pull also over to this point so that I have all of my address lines lined up in a row here. Here's the concern. Make sure I've got this oriented the right way. If my new replacement EEPROM board is going to sit like this and about in that position, I have 2 problems. One, I need to find something I can hang it out over that's not going to be intrusive. And 2, I have no place in here then to plug in a ribbon cable in order to drag those out. So I need to manufacture a spot over here for that. Now, if I go right up to here, this whole second, whoops, let's get that lined up right. Almost this entire outside row will be available for that. And I'm just going to go ahead and take 15 positions here for that. My output is going to be directly pulled over to this IC. So I can come out directly straight out from underneath, come up and over the IC like I did originally, and the other IO pins I can pull out directly onto here. So that's not going to be a challenge. I only need to be concerned with where I'm going to plug in my ribbon cables over here. Let me get this wired up here. It'll take me a little bit to do. Now I'm sure you're going to immediately want to ask, Adam, you just tied some of those address lines low and now you're pulling them out to a common spot where you can add in your ribbon cable to jump off to the rest of the build. Yes, I did, and they're not going to be used at the moment, so I do need to tie them low somewhere. May as well be in the first one that I do. That gives me one place to come back to and remove those connections when I start using them. Okay, I've done something wrong here. I've missed something. There's an 1/8 that needs to go in. And I'll make this one a different color to indicate pin 0. Now, I will call out that the outputs of this latch are actually up underneath all of these wires, so it might have been better for me to work my way from right to left as opposed to left to right. But I'm not going to lose any sleep over that here. I can get that fixed pretty easily. I do need a clock signal here on this pin, and I'll pull the clock from over here. Just realized I counted wrong, so I have to add another demultiplexer in here. And this now is going to eliminate my ability to extend everything out to the end here as a jump point off to other locations. I'll have to live with that. Now, the most significant 2 bits up here are going to drive this demultiplexer. The remaining 6 bits are going to drive these 7 demultiplexers, and here's how that's going to work. The top 3 of those 6 bits are going to drive this demultiplexer, the output of which is a low. So this will be driving an enable on one of these 6 demultiplexers. The lower 3 bits coming off the latch up here are going to drive each of these 6. So that the top 3 bits selects which of these ICs is active, and then the lower 3 bits selects which channel within that is active. So other than connecting the outputs, I believe this should be ready to go. I've got the full build back out again, and the whole goal is to separate these 2 breadboards out of the build so that I can replace it with the ones that I have just worked on. And I'm looking at this and thinking this is still quite a disaster, and I probably need to do something about cleaning this up because it's going to improve how things go from here. This is the board that I am using to bring all of my control signals in order to turn around and jump them off to the registers over here. So let's start with another fresh board. I have down here 6 10-pin connectors for all of the inputs, control signal inputs, into this module here. What I think I want to do is I want to line them up down here along the bottom, and I'll bring power and ground over. But what I should be able to do then is line these up in a row across one breadboard for one backplane of 6 registers. Then if I bring all of my control signals down and drop them into the top up here, I can cross connect as needed. This is part of the ALU, which has no business being on this board to begin with. And I'm going to deinstall this. I start by removing some ALU components, set carry, clear carry, which don't really belong on the boards there. Then I start to relocate the control signals, which go back off to the register backplane. I add the hardwired 5-volt signals, extend the clear signal to all of the drop points for all the registers. Then I add pull-up resistors. Finally, I get into tracing out and relocating all of the necessary signals in order to remove the old control logic 1. Finally, I get to the point where I can remove the old jump board, but I can't, so I just relocate that to the bottom. Finally, I get to the point where I can insert the new control logic 1 board. I connect all the new signals for the control logic 1, and I had to cut solid core wires for some of them because the lengths were so long. I just was not able to piece things together. Now can I remove the old control logic? Finally, I extend the clock and add power and ground, and that's a lot of change. All right, well, let's just say that is a heck of a lot of change without being able to test anything. I need to clean up quite a bit of mess now. Just general straightening of the desk. I'm going to have to hook up power and ground better make sure that I've got enough cross connects here. And then I've got to go through and double check every one of these connections, particularly around here where I've got hard connections to 5 volts. I want to make sure I don't have that cross connected back to any one of these ICs accidentally. That would ruin my day. That's going to be quite a bit of checking, so I'm going to do that off camera. And when I come back, I'll be prepared to power things up. Be back in a minute. I think I'm ready. I double checked the clock to make sure that it wasn't accidentally grounded. I double checked VCC and ground over here to make sure that it wasn't, I don't have a short anywhere. I did double check all of my lines that have a go off to the outputs of one of these ICs, and nothing is connected directly to 5 volts there. Let's plug this in, and let's go for broke. Okay, power's on. I am properly at reset, and it did load the first instruction. Now this is my R2 test. Okay. So program counter did not increment, and I did not pass the I did pass the instruction up to the instruction register here underneath all of this mess. This boiled down to 2 key issues. Number 1, I was not hooked up to the clock. And number 2, I had the ground line for the AND IC hooked up in the wrong spot. No, I didn't hurt it. I've got it plugged in the wrong. I never got it properly powered after I removed that strip there. Now R2 is not loading the correct value. Okay, that looks like my delay up here. So more specifically, I've created more of a delay in here than I had accounted for up here. And so now I actually have to add more of a delay up here. For me to do that, I'm going to have to grab the oscilloscope and take a look at that one more time, hoping it will work good enough. Okay, quick test here. Just added an inverter, actually 2 inverters in there just to see if that would give me what I need. No, it does not. Let me add in the others. I don't know that that's actually the problem. I managed to get this somewhat working. I did that by replacing the USB power and interface that I have connected to my laptop. It settled out the power, so I probably have some bad capacitors in that other one, and I'll get to that repair another time. But there's some damage that's been done here as well, because I believe that if I turn this on, that seems to actually be working correctly now, interestingly enough. And see, now I've got it inverted, so I'm not exactly sure what's going on here. I'm not seeing the spike I'm expecting to. So Control 2, this clock is supposed to be the spike clock. So let's put that there and see what that does. That's working. Okay, so I ended up adding in a huge extra delay here. Let's see if that's still required. It is not required. So this can all go away. And that is working just as I hoped it would. Okay, just to be complete, I'm going to program the memory with the code to test register 1, just to make sure I don't have anything going on there. Yep, R1 works too. Well, at this point, you're probably thinking, well, Adam, you said one of the purposes was to clean up some of this mess. It is. I'll start by cleaning up the last temporary hookup wire on the clock. Then I'll move into taking that clock rail and flipping it around so that I have the ability to tie that into the breadboard that I just stuck in between these two. Next, I've got several ribbon cables that I want to install and bring around to this jump interface or connection board, if you will. These are quite long, and the plan is to increase the number of control modules I have, which would increase the distance between the First, control logic module and this jump board. The final two tasks are to clean up the signals for the spike clock and replace the address lines for control ROM 3 with something that's just a smidge longer. Okay, the last task today is I actually want to replace this contraption here with a new contraption that's done on this solderful breadboard. It's going to be exactly the same feature functionality. It's just going to be on a soldered breadboard rather than soldered strip board. Let me get the microscope out so we can get started. Okay, it's not like I'm going to solder through hole components under a microscope. I do still have a very similar problem to what I had with the strip board, and that is that I actually need to separate the traces. So I had to cut and scratch that away, and I had to cut and scratch that away. Now what makes this different than the strip board is it's two-sided and the connections are on both sides. So I actually had to cut and scrape away on the other side as well. Now I did test and I have actually separated the traces, so I should be good there. And let me get the soldering iron warmed up. I start off by soldering the pins that I'm going to use to connect to the breadboards and into the EEPROM. I want those as flush as possible so that the cradle can sit flat. Then I take care of the jumpers that I need in order to connect power off to the side. And then I add the cradle in. Now I will say that the copper is so shiny that it makes it very difficult to actually see the pins. Now I'm going to take the actual power and I'm going to take that to the lower rail. We'll put in the pull-up resistor. And then the upper power rails are going to be used for powering the IC itself. Next, I'll set the relay. Now,
the coil is to the left and it's going to be closest to the battery.
The common is next over from that, next to the right, followed by the battery connectors, and then the
powered 5-volt rail off the pins
is going to be farthest to the right. Next, I hook up the battery connector, and I want to extend those pins down to the bottom of the board, simply because it'll make it easier for all the connections I've got to do. Okay, so the next day I go ahead and start actually doing all the wire up necessary to make all the connections to the relay. Now this is no different than the previous iteration of the EEPROM replacement. I'll stick a link up in the corner or in the description for the previous video on this. I believe this is complete. As I was straightening up, I realized I did not install the capacitor in order to provide power during the transition. So let's get that installed. I have to admit, that was fussy, though not nearly as bad or not nearly as fussy as it would have been with the strip board. To test this, no battery, just in a breadboard. I don't know if you can pick it up, but the relay is clicking. Okay, so that's good. And then if I probe here and here, I should have 5 volts. Let's try it on volts, Adam. Yeah, should have 5 volts. And if I disconnect it, I should remain. I'm expecting this to hold power. I guess it's holding 1.2 volts. That's not horrible. Yeah, it's dropping quickly. Now with no power, let's check and make sure that the battery would power the IC. That's good. Positive should be here, and that is good. So let's double check that one more time. With power, from here to, let's see, that is negative. So from there to there should be disconnected. From there to there should be disconnected. Now with a coin battery in there, I should have 3 volts here where the IC would be. I've got 5. It's because I'm plugged in. Disconnect, I should have now 3 volts. And I should have 3 volts there, which I do. Okay, that looks good enough to insert an IC. And then the next task is, because this sits so low now, I actually need to raise it in order to get it into the EEPROM. So I have to extend the pins a little bit in order to raise it up for the Tommy Prom. So let's see what the Tommy Prom has to say about it. I'm connected, it's powered on. Let's try zapping test pattern, and that looks good. And let's go for broke. Let's just go ahead and write the entire thing. That looks right to me. That looks very good. All right, next step is to get the build out. Well, let's try, before I do that, let me power it off, power it back on, and yes, it is holding data, so that's good. All right, let me get the build back out. We'll give this a test. This is going to take the place of this. Now, it has been programmed with the same code, so it should work right out of the chute. That looks like I've got power and ground lined up. All right, let's give this a shot. Okay, I powered it up, and for whatever reason, it caused my USB to glitch. That's not a good thing. But it did power up clean. Okay, my load instruction is up here. That's R1 now still. And that worked. Yeah, that's working just fine. Well, that was quite the whirlwind. I'm happy to have these changes complete. It's going to set me up well for the remainder of the build. I do need to make the same changes to control ROM 2 and control ROM 3. Plus, I need to earmark a spot for control ROM 4, which will be coming in the future here shortly. In order to do that, I have to reorganize some of the control signals in order to make them make some more logical sense. So look for that in the next video as well. There will more than likely be something that doesn't work that I'm going to have to troubleshoot. My whole goal here is to get to the point where I can get the ALU back into the build and start looking at the timing associated with that. And I do still have some concerns on those timings to make sure that things are going to work the way that I need them to. Hopefully I can still get the performance I'm looking for, but my expectations on that are waning. I was hoping to get 10 megahertz out of it. At this point, I'd be satisfied with 7. I'm learning. We'll see you soon.